Human Odyssey, Migration of Early Modern Humans. The migration of early modern humans is a profound and defining element of human history. Tracing the journey from our origins in Africa to the farthest corners of the globe provides insights into the adaptability, resilience, and ingenuity of our species. The process of human migration involves understanding the various routes taken, the environmental challenges faced, and the cultural transformations experienced by our ancestors. This intricate tapestry of movement and adaptation has shaped the genetic, cultural, and social landscapes of contemporary human populations. Studying human migration is crucial for multiple reasons. It helps us understand the genetic diversity present in modern populations and the historical connections between different groups. By analyzing migration patterns, researchers can uncover the interactions between early human groups and their environments, shedding light on how humans have adapted to diverse and changing climates. Additionally, the study of migration provides context for the spread of technological innovations, languages, and cultural practices, illustrating how interconnected human societies have been throughout history. Understanding these migrations also informs contemporary discussions on identity, heritage, and the movement of people in a modern, globalized world. The methodology for studying early human migration is interdisciplinary, involving genetics, archaeology, anthropology, and climatology. Genetics. Scientists look at DNA, especially mitochondrial DNA and Y chromosome markers, to trace where our ancestors came from and where they moved. Archaeology. By studying ancient tools, art, and old dwelling sites, archaeologists find physical evidence of where humans lived and traveled. Anthropology. This field examines cultural artifacts and social structures to understand how ancient people lived and moved. Climatology. Understanding past climate conditions helps scientists see how weather and environment changes influenced human migration. By weaving together genetic data, archaeological findings, and environmental reconstructions, researchers can piece together the migration paths of our ancestors. The study of early human migration not only unravels the history of human movement, but also highlights the remarkable adaptability and resilience of our species in the face of changing landscapes and climates. This exploration of our past migration patterns ultimately enriches our understanding of human history and the enduring quest for survival and adaptation. Origins of anatomically modern humans. The origins of anatomically modern humans, Homo sapiens, are traced back to Africa, where several evolutionary milestones mark the emergence of our species. The development of larger brain sizes, sophisticated tool use, and complex social behaviors are pivotal stages in human evolution. These milestones collectively define the transition from earlier hominins to anatomically modern humans, setting the stage for subsequent migrations out of Africa. Genetic evidence, particularly from mitochondrial DNA and Y chromosome studies, supports the out-of-Africa hypothesis, which posits that all modern humans have a common origin in Africa. Genetic markers trace lineages back to a small population that lived in Africa around 200,000 to 300,000 years ago. Fossil records complement this genetic evidence, providing physical remains that illustrate the morphological characteristics of early modern humans. These fossils exhibit traits such as a high, rounded skull, a prominent chin, and reduced brow ridges, distinguishing them from archaic human species. Key fossil sites such as Homo kibish, Herto, and Jebel Irhoud are critical in understanding the origins of anatomically modern humans. Homo kibish in Ethiopia has yielded some of the oldest known Homo sapiens fossils, dated to approximately 195,000 years ago. These remains show clear anatomical features of modern humans, making them among the earliest evidence of our species. Herto, also in Ethiopia, provides fossils dated to around 160,000 years ago, with a mix of archaic and modern traits. suggesting a transitional phase in human evolution. The Jebel Irhoud site in Morocco has produced fossils dated to about 300,000 years ago, significantly pushing back the timeline for the emergence of modern humans. These remains include a skull with modern facial features, but with a more archaic brain case, indicating a complex evolutionary process. 2. Out of Africa theory. The out of Africa theory, also known as the recent African origin model, posits that anatomically modern humans, Homo sapiens, originated in Africa before migrating to other parts of the world. This theory is supported by a wealth of genetic, fossil, and archaeological evidence, which collectively illustrate how our ancestors left Africa and spread across the globe. The African cradle refers to Africa as the birthplace of modern humans. Genetic studies have shown that all non-African populations descend from a relatively small group that left Africa around 60,000 to 70,000 years ago. This group carried with them the genetic diversity that would eventually populate the rest of the world. Fossil records from Africa, such as those from Homo kibish and Herto, show that modern humans had developed distinctive anatomical features in Africa well before they began migrating out. The first migratory routes taken by modern humans are believed to have followed the coastal and inland paths through the Arabian Peninsula into Asia and Europe. These routes were likely influenced by climatic conditions, sea levels, and the availability of resources. The mechanisms of dispersal included gradual population movements driven by ecological pressures, such as changes in climate and the search for new habitats. These migrations involved small groups that moved relatively slowly over generations, adapting to new environments as they went. Archaeological evidence from the Arabian Peninsula plays a crucial role in understanding these early migrations. Sites like Jebel Faya in the United Arab Emirates have yielded stone tools that resemble those made by early modern humans in Africa. These tools, dated to around 125,000 years ago, suggest that humans may have left Africa earlier than previously thought, using the Arabian Peninsula as a corridor to reach other parts of Eurasia. This region's archaeological record indicates that humans adapted to the harsh desert environment, utilizing resources along coastal and inland routes. Early archaeological evidence outside Africa includes significant findings in regions like Israel, Southeast Asia, and Australia. In Israel, the Skul and Kafze caves contain human remains dated to around 90,000 to 120,000 years ago, showing an early but temporary presence of modern humans in the Levant. In Southeast Asia, sites such as Tam Pa Ling in Laos and Majed Bebe in Australia have provided evidence of human occupation dating back to around 63,000 and 65,000 years ago, respectively. These findings indicate that modern humans had reached far-flung regions relatively quickly after leaving Africa, adapting to diverse environments from tropical forests to arid deserts. 3. Interactions with other hominins. The migration of early modern humans out of Africa brought them into contact with other hominins, such as Neanderthals in Europe and Western Asia, and Denisovans in Asia. These interactions were complex and had significant implications for the genetic and cultural development of modern humans. Neanderthals and Denisovans were close relatives of modern humans, sharing a common ancestor approximately 600,000 years ago. Neanderthals, Homo neanderthalensis, primarily inhabited Europe and parts of Western Asia, while Denisovans, a more enigmatic group identified from remains found in the Denisova cave in Siberia, spread across Asia. Both hominin groups had adapted to their respective environments, developing distinct physical and cultural traits. Evidence of interbreeding between early modern humans and these archaic hominins has been established through genetic studies. Analysis of modern human genomes reveals that non-African populations carry small percentages of Neanderthal DNA, typically around 1–2%. Similarly, Melanesian and some other Asian populations possess Denisovan DNA, with some individuals having up to 5% Denisovan ancestry. This genetic mixing occurred during periods of coexistence, as early modern humans migrated into territories already inhabited by Neanderthals and Denisovans. Fossil evidence, such as the remains of a child with mixed Neanderthal and Denisovan ancestry found in the Denisova cave, further supports these findings. Cultural exchange likely accompanied genetic interbreeding. Early modern humans and Neanderthals shared some technological and behavioral traits, such as the use of sophisticated tools, fire, and possibly symbolic behavior. The discovery of similar stone tool technologies and the presence of ornaments and burial practices among Neanderthals suggest that cultural interactions occurred. This exchange of ideas and technologies may have provided early modern humans with advantageous adaptations to new environments. The impact of interbreeding on modern human genetics extends beyond the mere presence of archaic DNA. Some Neanderthal and Denisovan gene variants have been associated with adaptive advantages in contemporary populations. For example, certain Neanderthal genes are linked to immune system functions, helping early modern humans combat new pathogens encountered outside Africa. Denisovan genes have been associated with high-altitude adaptation, aiding populations living in the Tibetan Plateau. However, the legacy of interbreeding is not solely positive. Some Neanderthal gene variants have been linked to modern health issues, including susceptibility to certain autoimmune diseases, type 2 diabetes, and nicotine addiction. This complex legacy highlights the nuanced role of archaic hominin DNA in shaping the genetic landscape of modern humans. IV. Colonization of Asia. The colonization of Asia by early modern humans is a key chapter in the story of human migration, marked by diverse routes, significant adaptations, and the establishment of early settlements that led to remarkable genetic and cultural diversity. Routes into the Indian subcontinent were among the earliest migration paths taken by Homo sapiens after leaving Africa. These migrations likely occurred through multiple waves and routes, including a coastal route along the Arabian Peninsula into South Asia. Archaeological evidence, such as stone tools found in the Jwalapuram site in India, suggests human presence as early as 74,000 years ago. Another possible route was through the inland corridor via the Levant and Iran. These routes allowed early humans to bypass the harsh conditions of the Central Asian deserts, providing access to more hospitable environments with abundant resources. Adaptation to Asian environments required significant changes in lifestyle and technology. The Indian subcontinent presented a range of ecological zones, from tropical forests to arid plains, each necessitating different survival strategies. Early humans developed region-specific tools and techniques, such as microliths in South Asia, which were small, sharp stone tools suited for hunting and processing plant materials. The diverse climates also influenced dietary practices, with populations relying on a mix of hunting, gathering, and eventually, early agricultural practices. Early settlements in East and Southeast Asia further illustrate the adaptability and resilience of early modern humans. In East Asia, archaeological sites, such as Zhoukoudian Peking Man site in China, provide evidence of human habitation dating back to around 40,000 years ago. These early settlers used a variety of tools and are known for creating some of the earliest known pottery. In Southeast Asia, the Naya Cave in Borneo and Tam Pa Ling in Laos show evidence of human presence from around 46,000 to 63,000 years ago. These sites indicate that early humans in this region adapted to tropical rainforest environments, developing hunting techniques and tool technologies suitable for dense forests. Genetic and cultural diversity in Asia is a testament to the complex history of human migration and adaptation. Genetic studies reveal significant variation among Asian populations, reflecting both ancient migrations and more recent interactions. The presence of Denisovan DNA in some Southeast Asian and Oceanian populations indicates interbreeding events that contributed to the genetic mosaic of the region. Cultural diversity is equally rich, with early humans developing distinct languages, traditions, and social structures. For example, the diverse linguistic landscape of the Indian subcontinent and Southeast Asia showcases the deep historical roots and interactions of various human groups. Peopling of Europe. The peopling of Europe by early modern humans is a significant chapter in the human odyssey, marked by initial settlements, diverse migration routes, and the development of regional cultures. This process involved adapting to the unique European climate and resulted in a rich tapestry of cultural and genetic diversity. Initial settlements and migration routes into Europe were influenced by various geographic and climatic factors. Early modern humans likely entered Europe from the Near East around 40,000 years ago. The Levantine corridor served as a critical passage, facilitating movement into southeastern Europe. Another possible entry point was the Mediterranean coast, which provided a relatively mild climate and abundant resources. The Danube River corridor is also believed to have been a significant route, guiding early humans from the Black Sea region into Central Europe. Europe's arrival and settlement patterns were shaped by its diverse landscapes, from coastal regions to mountainous areas. Early settlers favored locations with rich natural resources, such as river valleys and coastal plains, due to their abundant food sources and favorable living conditions. The development of regional cultures in Europe is evident from diverse archaeological records, showcasing distinct technological and artistic traditions. One of the earliest cultural expressions is the Aurignacian culture, noted for its sophisticated stone tools and cave art. This was followed by the Gravettian culture, which featured advanced hunting techniques and the production of Venus figurines, indicating a complex symbolic and social life. Later, during the Upper Paleolithic, the Magdalenian culture emerged. Renowned for its intricate bone and antler tools and elaborate cave paintings, such as those in Lascaux, France. Sites like the Aurignacian caves and the Gravettian locations in Central Europe provide evidence of early human occupation and their sophisticated tool-making abilities. These settlements demonstrate a pattern of seasonal mobility, with groups moving between different habitats to exploit seasonal resources. Adaptation to the European climate was crucial for the survival of early modern humans in this new environment. Europe's climate varied significantly, from the temperate Mediterranean regions to the colder northern areas. Early humans developed a range of adaptive strategies to cope with these conditions. This included the use of tailored clothing made from animal hides, the construction of shelters such as mammoth bone huts, and the utilization of fire for warmth and cooking. Genetic adaptations also played a role. For instance, lighter skin pigmentation evolved to optimize vitamin D synthesis in regions with lower sunlight levels. 6. Settlement of Oceania. The settlement of Oceania represents a remarkable feat of maritime migration, characterized by the Austronesian expansion, advancements in maritime technology, and the establishment of communities on remote Pacific islands. This process left a rich legacy of archaeological and genetic evidence, revealing the complex history of human settlement across vast oceanic distances. Maritime migration. The Austronesian expansion was a pivotal movement that began around 3000 BCE from Taiwan, spreading through the Philippines, Indonesia, and into the vast expanse of the Pacific Ocean. The Austronesians were highly skilled navigators and seafarers, capable of long-distance ocean voyages. Their expansion led to the colonization of numerous islands in Southeast Asia, Melanesia, Micronesia, and Polynesia. By 1000 BCE, they had reached the Western Pacific, and by 500 CE, they had settled islands as far-flung as Hawaii, Easter Island, and New Zealand. The role of maritime technology was crucial in enabling the Austronesian expansion. The development of advanced outrigger canoes and double-hulled voyaging canoes allowed these early navigators to undertake long and risky voyages across open seas. These vessels were sturdy, swift, and capable of carrying large numbers of people along with supplies, domesticated animals, and plants. The Austronesians also developed sophisticated navigation techniques based on the stars, ocean currents, wind patterns, and the flight paths of birds, which allowed them to find and return to distant islands reliably. Settling remote Pacific islands involved both planned voyages and exploratory trips. Once suitable islands were discovered, settlers established sustainable communities by bringing with them essential plants and animals, including taro, yams, breadfruit, pigs, chickens, and dogs. These introductions were crucial for ensuring a stable food supply. The ability to adapt to the diverse environments of the Pacific Islands, from volcanic archipelagos to atolls, was key to the successful colonization of Oceania. Settlement patterns in the Pacific Islands varied depending on the geographical and environmental conditions of each island group. Larger, resource-rich islands like Fiji and Samoa supported more complex societies with hierarchical structures and advanced agricultural practices. In contrast, smaller atolls and islands like those in the Marshall Islands or Tuvalu developed more egalitarian and simpler social organizations due to limited resources. Trade networks and voyaging remained essential for these communities, ensuring the exchange of goods, ideas, and cultural practices across the vast distances of the Pacific. Archaeological and genetic evidence provides a comprehensive picture of the Austronesian migration and settlement of Oceania. Archaeological findings, such as Lapita pottery, which dates back to around 1500 BCE, serve as markers of early Austronesian presence in the Pacific. These intricately decorated ceramics have been found from the Bismarck Archipelago to Samoa, illustrating the spread of these early settlers. Genetic studies further support the archaeological evidence, showing a distinct genetic lineage that links modern Pacific Islanders to their Austronesian ancestors. Analyses of mitochondrial DNA and Y chromosome markers reveal patterns of migration and inter-island connections, confirming the widespread and interconnected nature of early Pacific communities. 7. Entry into the Americas. The entry of early modern humans into the Americas is a key chapter in the story of human migration, marked by different theories, significant adaptation, and the development of unique cultures. This migration led to the peopling of a vast and diverse continent, leaving behind a rich archaeological record. Theories of migration. Land bridge versus coastal routes focus on the different possible paths early humans took to enter the Americas. The two main theories are the Bering Land Bridge theory and the coastal migration hypothesis. Both theories propose distinct routes and mechanisms by which humans could have migrated from Asia into North America. The Bering Land Bridge theory posits that during the last glacial maximum, around 20,000 years ago, sea levels were significantly lower, exposing a land bridge known as Beringia between Siberia and Alaska. This bridge provided a route for humans, as well as flora and fauna, to migrate from Asia into North America. Archaeological evidence, such as tools found in Beringia, supports this theory, indicating that humans might have used this route to enter the Americas when the climate allowed. Clovis theory, closely related to the Bering Land Bridge theory, is based on the discovery of distinctive stone tools associated with the Clovis culture, first found near Clovis, New Mexico in the 1930s. The Clovis tools, characterized by their fluted points, date back to around 13,000 years ago and are among the earliest evidence of human activity in North America. Proponents of the Clovis theory initially suggested that the Clovis people were the first inhabitants of the Americas, migrating via the ice-free corridor once it opened. Coastal and inland routes propose alternative and complementary paths for human migration into the Americas. The coastal migration theory suggests that early humans traveled along the Pacific coastline, utilizing boats and exploiting marine resources. This theory is supported by archaeological finds along the North and South American west coasts, where early sites show signs of human habitation. These coastal routes would have been accessible even when inland routes were blocked by ice sheets. Inland routes, once the ice sheets began to retreat around 16,000 years ago, opened corridors such as the ice-free corridor, allowing further migration into the heart of North America and beyond. Development of early American cultures followed these initial migrations, leading to a rich diversity of cultures and societies across the continent. Early inhabitants adapted to a wide range of environments, from the Arctic tundra to temperate forests, deserts, and tropical rainforests. This led to the development of various subsistence strategies, including hunting megafauna, fishing, and gathering. Over time, these early populations developed sophisticated tools, art, and social structures. These diverse adaptations and innovations set the stage for the complex societies that would eventually emerge, from the mound-building cultures of the Mississippi Valley to the advanced civilizations of the Maya, Aztec, and Inca in Central and South America. Archaeological sites in North and South America provide evidence of these early cultures and their development. In North America, sites such as Clovis, New Mexico, show evidence of one of the earliest known cultures, the Clovis culture, dating back to around 13,000 years ago. The distinctive Clovis points found at these sites indicate advanced hunting technologies and widespread trade networks. In South America, sites like Monte Verde in Chile, dated to around 14,500 years ago, offer some of the earliest evidence of human settlement in the region. Monte Verde's artifacts include wooden structures, tools, and food remains, indicating a well-established community. Other significant sites include the Anzic site in Montana, where the remains of a young child buried with Clovis tools were discovered, providing insights into the burial practices and genetic makeup of early North Americans. The Pedra Furada sites in Brazil, with evidence of human occupation dating back over 20,000 years, challenge traditional timelines and suggest an even earlier presence in the Americas. Fee 8. The role of climate in migration. The role of climate in migration is a critical aspect of the human odyssey, influencing the routes, timing, and success of early modern human movements across the globe. Climate changes, particularly during the Ice Ages, played a substantial role in shaping migration patterns and the development of human societies. Impact of ice ages and climate fluctuations on human migration cannot be overstated. The Pleistocene epoch, characterized by repeated glacial and interglacial periods, created fluctuating environments that either facilitated or hindered human movement. During glacial periods, vast ice sheets covered large parts of North America, Europe, and Asia, lowering sea levels and exposing land bridges such as Beringia between Siberia and Alaska. These land bridges provided critical migration routes for early humans. Conversely, the harsh, cold climates and ice-covered landscapes of glacial periods often limited habitable areas, concentrating human populations in refugia, areas that remained relatively ice-free and hospitable. Climate change and human movement were closely intertwined. As climates warmed during interglacial periods, ice sheets retreated, opening new regions for habitation and migration. Warmer climates allowed forests, grasslands, and other ecosystems to expand, providing abundant resources for hunter-gatherer populations. These changes often spurred migrations into previously inaccessible areas, such as the movement of Homo sapiens into Europe and Northern Asia around 40,000 to 50,000 years ago as the climate ameliorated. Environmental challenges and migration patterns were shaped by the need to find reliable food sources and favorable living conditions. During periods of climatic instability, early humans were often forced to migrate to more hospitable regions. For instance, the last glacial maximum, around 20,000 years ago, drove human populations southward into refugia in southern Europe, Asia, and North Africa. As the climate warmed, these populations expanded northward and into new territories. The ability to adapt to diverse and changing environments was crucial for survival, leading to the development of varied subsistence strategies and technologies. Impact on habitats and resources from climate changes influenced the availability of food and the suitability of living areas. Glacial periods often resulted in the expansion of steppe tundra environments, which supported large herds of megafauna such as mammoths, bison, and reindeer. Early humans adapted by developing specialized hunting techniques and tools to exploit these resources. In contrast, interglacial periods saw the spread of forests and other rich ecosystems, allowing for a more diverse diet and the development of gathering and fishing techniques. Changes in sea levels also affected coastal habitats, opening new areas for human settlement or submerging previously inhabited regions, thereby influencing migration routes and settlement patterns. 9. Cultural and technological innovations. Cultural and technological innovations played a crucial role in the migration and success of early modern humans. These innovations facilitated not only survival, but also the flourishing of complex societies. Key areas of development include language and communication, tool-making and art, and the establishment of social structures and trade networks. Development of language and communication and symbolic thought was fundamental to human migration and social organization. The emergence of complex language allowed early humans to share knowledge, plan hunting strategies, and transmit cultural practices across generations. This ability to communicate effectively would have been critical during migrations, enabling groups to coordinate movements and adapt to new environments. Symbolic thought, evidenced by the use of symbols and abstract concepts, is reflected in early human art, burial practices, and rituals. These cognitive advancements facilitated a sense of shared identity and community, crucial for cooperative behaviors and social cohesion. Tool-making and art represent significant technological and cultural milestones. Early modern humans developed a variety of sophisticated tools tailored to specific tasks such as hunting, processing food, and crafting clothing and shelters. The Upper Paleolithic period, starting around 40,000 years ago, saw the proliferation of finely crafted stone blades, bone tools, and composite tools, which combined different materials for enhanced functionality. Art, in the form of cave paintings, carvings, and portable objects, provides insight into the symbolic and aesthetic aspects of early human life. Sites such as Lascaux in France and Altamira in Spain, with their intricate cave paintings of animals and abstract symbols, demonstrate a high level of artistic skill and symbolic thinking. Social structures and trade networks developed as humans settled into diverse environments, leading to more complex societal organization. Early humans formed kinship-based groups, with social roles and responsibilities often shared within the community. These groups were typically egalitarian, but as populations grew and resources became more abundant, more hierarchical structures began to emerge. Trade networks also expanded, allowing for the exchange of goods, ideas, and technologies across regions. Evidence of long-distance trade can be seen in the distribution of materials such as obsidian, shell, and exotic stones, which were transported over considerable distances. These networks facilitated not only economic exchange, but also cultural interaction, contributing to the diffusion of innovations and the development of regional identities. X. Modern human diversity and distribution. Modern human diversity and distribution is a reflection of the complex history of human migration, adaptation, and cultural evolution. From genetic diversity and population structure to cultural diversity and ongoing migration patterns, the story of modern humans is one of continual movement and adaptation. Genetic diversity and population structure among modern humans can be traced back to our origins in Africa and the subsequent migrations that spread our species across the globe. Genetic studies have shown that African populations exhibit the greatest genetic diversity, reflecting the long period of time humans have lived on the continent. As populations migrated out of Africa, genetic diversity decreased due to bottlenecks and founder effects. However, the mixing of populations through migration has introduced new genetic variations. Population structure varies widely, with distinct genetic markers identifiable among different regional groups, yet also showing evidence of interbreeding and gene flow between populations. Cultural diversity across continents is another testament to the adaptability and innovation of human societies. Each migration wave brought humans into new environments where they developed unique cultural practices, languages, and technologies. In Africa, diverse ethnic groups have distinct languages, traditions, and social structures. In Asia, cultures range from the ancient civilizations of Mesopotamia and the Indus Valley to the nomadic tribes of the steppes. Europe's cultural landscape has been shaped by ancient migrations, the spread of empires, and modern nation-states. In the Americas, indigenous cultures developed complex societies such as the Maya, Inca, and Aztec, each with their own advancements in agriculture, architecture, and governance. The Pacific Islands display a rich tapestry of cultures connected through maritime navigation and trade. Modern human diaspora refers to the widespread movement of people in more recent history, facilitated by advancements in transportation and communication. The transatlantic slave trade, European colonization, and the movements of indentured laborers significantly altered population distributions and cultural landscapes. The 19th and 20th centuries saw mass migrations due to industrialization, wars, and political upheaval. These movements have led to the creation of multicultural societies, particularly in countries like the United States, Canada, Australia, and various European nations, where diverse populations coexist and contribute to the cultural mosaic. Ongoing migration patterns continue to shape human diversity and distribution. Globalization, economic opportunities, political conflicts, and environmental changes drive modern migration. Economic migrants seek better opportunities, while refugees flee conflicts and persecution. Climate change is increasingly influencing migration, with rising sea levels, droughts, and natural disasters displacing communities. Modern technology and transportation facilitate rapid and large-scale movements, creating dynamic and ever-changing demographic patterns. The flow of people brings new challenges and opportunities for integration and cultural exchange, highlighting the continuing story of human movement and adaptation. Conclusion. The migration of early modern humans is a profound and defining element of human history, tracing our journey from origins in Africa to the farthest corners of the globe. This journey, marked by adaptability, resilience, and ingenuity, provides insights into the genetic, cultural, and social landscapes of contemporary human populations. Africa's central role in human evolution is highlighted by genetic evidence and fossil records from sites like Homo and Jebel Irhout, showing early modern human traits. The out-of-Africa theory describes our ancestors' migration routes, such as the Bering Land Bridge and coastal paths into Asia, with archaeological evidence from the Arabian Peninsula illustrating these complex dispersals. Adaptations to new environments, including advanced tools, fire control, and agrarian societies, demonstrate human ingenuity in overcoming environmental challenges. Interactions with other hominins, like Neanderthals and Denisovans, enriched our genetic and cultural heritage. The colonization of Asia, Europe, and Oceania involved diverse migration routes and settlement patterns, while the entry into the Americas opened new chapters in human migration. Climate fluctuations significantly influenced these patterns, and cultural and technological innovations played crucial roles in adaptation. Modern human diversity and distribution reflect ongoing migration and adaptation processes. showcasing the dynamic and interconnected nature of contemporary populations. In conclusion, the human odyssey of migration and adaptation is a testament to our species' remarkable ability to explore, survive, and thrive in diverse environments. The journey from our origins in Africa to the establishment of complex societies across the globe underscores the interplay of genetic, cultural, and environmental factors in shaping human history. This exploration of our past migrations enriches our understanding of human diversity and the enduring quest for survival and adaptation.